Alright students, here's the topic list for tomorrow's quiz. We have on there graphical analysis. So if you have not figured out how to find the slope of a line, make sure you can do that on this quiz. We have position, distance, and displacement. If I show you a graph of something moving around, can you figure out its distance? Can you figure out its displacement? Inquiring minds want to know. Your quiz tomorrow will find out. Position time graphs. Can I show you a graph of an object's position over time, and you tell me where it is at a certain time, you tell me how far it's moved in a certain time period? Position time graphs. Relating position time graphs and velocity time graphs, that's what we did with the motion detector when we took all those position time graphs and turned them into velocity time graphs. So make sure you can do that. Finding displacement graphically. This is the area under the velocity time graph. We did this today in class. Make sure you're ready on that. There are extra practice sheets, I do believe, for pretty much all of these things. Maybe not finding the slope of a line, but you've done that a bunch now. Yeah, so take a look at the extra practice if you're shaky on any of these. I'm going to do quick examples and helpful hints throughout this video. Graphical analysis was on the last quiz, so you can look back at your last quiz. You can look back at the review video for the last quiz. You can look back at old posts. Finding the slope of the line on a graph. Got to be able to do it. That's all I'm going to say about that one because there's lots of resources for it on the website. Position, distance, and displacement. The first place I'm going to refer you is page 45 in your textbook, looking at chapter summary, and then where it says 2-1, position, distance, and displacement. That little, maybe quarter of a page there, summarizes most of what you need to know about position, distance, and displacement. So maybe take a second and read that, and then I'll show you a couple examples. So pause the video if you need to read that. Alright, simplest example I can think of. I'll do the simple one in green. Simple example. Someone walks 5 meters north or up, 15 meters from there, south, and those arrows are clearly not drawn to scale. Total distance, total displacement. So obviously total distance 5 plus 15 is 20 meters. Total displacement, we started right here, end up right here, and the difference between those is only 10 meters. Because I went 5 up, 15 back down, so difference from start to finish is 10 meters. And technically that should be 10 meters down. However, I'm going to ask you on the quiz tomorrow for a lot of magnitudes of displacement. So when you see the word magnitude, that word means just give me the number and not the direction. You still have to do start to finish, so it's not distance, even though it's magnitude, it's still displacement, but it means give me the displacement and leave off the direction. So if you see the word magnitude, that means do not include direction, just give the number part of it. Let me reiterate this because I don't want to confuse anybody. Magnitude doesn't mean distance, it means we're just leaving off direction. So if I ask you for the magnitude of displacement on this one, the answer would still be, oh, I don't know why I keep moving that around. If I ask you for the magnitude of displacement, the answer would still be 10 meters, it's just that you don't have to give a direction, okay? That's all the word magnitude means, you don't have to give a direction. Okay, now for my not easy, not hard, I'll do this one in yellow. Let's say I give you some object's starting position, and then the object goes in some weird path. And I ask you to find its displacement. I'm asking for from start to finish. In fact, I'm just going to go ahead and do a solid line. Displacement is from start to finish. And so there might be like numbers on this map where it tells you, oh, this little block right here is 3 meters, and then this block here is 2 meters, and this diagonal thing is 2.5 meters, and this part is some other number, whatever. Anyway, I'm just looking from start to finish, which would be the 3 plus the 2, start to finish, just going this way. And so there my total displacement would be 5 meters. And on a crazy path, I probably wouldn't ask you for distance, I'd just say displacement. So remember, it's straight from start to finish. You might have to make some inferences, like I might have, say, a box, and you go from this corner to this corner, but instead of giving you how big this side is, I give you how big this side is, like 2 meters. The right side of the box is obviously the same size. And I'm giving you that specific example because I think under a high-stress situation it could freak people out. You may actually have to make some inferences to solve those problems, okay? They're not super tricky. Alright, final example, hard one. I'll do this in red. And this is one that you have the least practice on, and you need to practice for tomorrow. Be ready for it. Let's say that I have a dude that, let's call him Spider-Man. Spider-Man climbs up the side of a building, 5 meters, and then along the roof, 12 meters. I want to know the magnitude of his displacement. So his displacement is from start to finish, this black vector or arrow I've just drawn. Find that. Why don't you pause the video, try to find that one. I'll come back and show you how to do it. Alright, this is a Pythagorean theorem problem. This side here is labeled C, this would be A, and this would be B. Remember that. C squared equals A squared plus B squared. So, C squared equals 5 squared, 5 meters squared, plus 12 meters squared. Right? C squared equals 25 square meters plus 144 square meters. Oh, I'm going to run out of space. I got to go below the triangle. Sorry about that. C squared equals 169 square meters. Then square root. C equals 13 meters. Alright, something you may want to know. This is really the only math-intensive type of problem on tomorrow's quiz. However, on tomorrow's quiz, you are not allowed a calculator. I repeat, you are not allowed a calculator. So you might want to practice the Pythagorean theorem, c squared equals a squared plus b squared, on a few triangles. So maybe make up your own a and b side and see what c would be. Alrighty, that's it for position, distance, and displacement. Alright, next, position time graphs. I think this one is pretty simple. I might give you a graph, tell you its position versus time, and then tell you that you have somebody who starts at some position. Let's just make up some numbers here. Let's say they start at 3 meters, and I'm just going to make up a time. We're not going to start at 0 just to show you that these can get complicated. Let's say he's at position 3 meters at time 2 seconds, right here, and then does something like this. And is at position 7 meters at time 6 seconds. Then I might say, what is the distance traveled between 2 seconds and 6 seconds? Or how far does the person travel in the 4-second interval shown? Whatever. Either way, you just say, okay, well, they started at 3, they end up at 7. The distance traveled is 4 meters. And then you might wonder, well, distance, does that mean I add in these flat parts? Nope. That person stands still there. They didn't cover a distance. So on a position time graph, if I ask you for the distance traveled, it's where did they start, where did they end. Be super, super careful that you don't just assume they started at the origin. Notice that my person here did not. Be very careful. Look at the graphs carefully. Okay? Alright, fair warning. Look at the graphs carefully. Also, pay attention to what the graphs are labeled. So you just learned today how to find displacement from a velocity time graph. If you thought that what I have on the screen here was a velocity time graph, you might start trying to calculate areas. And then you get the wrong answer, because this is not a velocity graph, this is a position graph. Be very careful, make sure you actually look at how the graphs are labeled, make sure you read the question, make sure you pay attention to where the graphs start and end. Tomorrow's quiz, the trickiest part is really pay very careful attention to what it's asking, okay? Alright, the other part is I might show you a graph and say a person walking in front of a motion detector made a graph like so. Then I might label it parts A, B, C, D, E, and say something like, when was the person moving forward and accelerating? Okay, so accelerating would be the curves, curve, moving forward here, going up the position time graph. Here would be accelerating and going backwards. Alright, here would be standing still, so forth. Read the questions carefully, look at the graphs carefully, think what would you have to do in front of the motion detector to make something happen. So pretty much just answering questions about what we did yesterday in class. Alright, relating position time graphs and velocity time graphs, this is what we did in class yesterday. I might show you some position or even distance time graph. For the purposes of these kind of questions, position and distance time would mean the same thing. So let's say I showed you this position time graph. I said figure out what its velocity time graph would be. Maybe take a second to do that, pause if you need to. Okay, this position time graph has a zero slope. It's a horizontal line, so velocity is 0. Okay, why don't you now try something like this position time graph. Try to figure out its velocity time graph. Pause if you need to. Right, here's the velocity time graph for that one, Vt. It is going down this way, negative slope, which means negative velocity. That negative velocity is constant though, so there's the velocity time graph for that one. I didn't draw my nice neat dotted lines, you had a whole day of people doing that in front of you. Alright, finding displacement graphically. This is what we did today in class. So you should have just had practice at it. It's basically just calculating the area of shapes, dividing them up into triangles and rectangles, and then finding areas. Pretty simple. The tricky part might be, so let's say I give you a velocity time graph that looks like this, and then it's labeled with times. I'm just going to make up some times. 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. Alright, so you might see a question that says, find displacement graphically given from this graph. And then, without reading the rest of the question, you might try to do it, and then you're going to screw up. Because I might throw in something that says, find the displacement from 3 seconds to 4 seconds, which would just be this area here. Okay? So you might do a lot of hard work and then find out you got it wrong just because you didn't read the complete question. So notice the key to this quiz that's coming up is really watching out for tricky questions. Or I might say, what's the displacement from 1 to 4 seconds? In which case it would be the area of these two triangles from 1 to 4 seconds. Or I might just say, what's the displacement from 3 to 5 seconds? Then it's the second triangle, and then this thing over here, which is a triangle and a rectangle, by the way. So you divide that up into this triangle and this rectangle. Don't try to do that one at the end. That's actually harder than what I would give you, mostly, because it doesn't have a whole second here, so you have to guess what the seconds are. It'd be very clear the sizes of your shapes. Alright, so if I give you a find displacement from velocity, read it super carefully, because what if I said just find it here? You might try to find the whole thing, it's really complicated for nothing. Or if I said find it here, and you try to do the whole thing, get the wrong answer. Or if I just said find it from 1 to 3 seconds. Point is, read the question carefully. And any of these things that you need more practice on, there's extra practice sheets. You can call or text me, you can call or text friends. Whatever you need to do. Alright, final reminders, there's no calculators on tomorrow's quiz. You will have 8 questions and 11 minutes to answer them in. So I think the timing shocked a lot of people last time. I think there are a lot of people who could have done really well if they'd had as much time as they needed. Not how an AP test works. Be ready to answer 8 questions in 11 minutes. They're all multiple choice tomorrow. Sometimes there will be free response quizzes, but tomorrow's is all multiple choice. 8 questions, 11 minutes, no calculators. That's it, and have a good night.